good time working on our exponents, and we're finally to our last lesson in this unit. And this one is on the negative exponent rule. And we could have actually seen it coming when we were doing our last couple of lessons, but on our last lesson we talked about the quotient rule, meaning that if you have exponents with the same base that you're dividing, all you have to do is subtract the exponents. And normally we would just subtract the bottom one from the top one, but in some cases the bottom one is bigger. So like in the example that you see here, if we subtract 2 minus 5, we would actually end up with a negative exponent. And we didn't want to have a negative exponent, so we actually moved it back to the bottom and made it a positive exponent. Or we kept saying, who has the most x's, the top or the bottom? And we said, the bottom does by 3. But what we're really trying to show you is that there's two ways to write this same thing. You could either write it with a negative exponent, x to the negative 3 power, like you see here, or you could write it like this, 1 over x to the positive 3 power. And that's what this general rule statement right here is indicating, that any negative exponent can be written as a positive exponent by just simply moving the exponent to the other side of the fraction bar and making it positive. And in the process of doing that, you may have to write down a 1 on the top. So we're going to have to practice a few of these to make sure we got it. So here we go. Now let's just iterate this statement right here. If the bases are the same, subtract the exponents and move the negative exponent and change it to a positive exponent. So basically what we're saying is, just like when we were using the Great Wall of China all year long, if we have a number on the left side, if we move it to the other side, it becomes its opposite. Or if it's positive, it becomes negative. Or if it's negative on the left side or the right side, and we move it across the equal sign, it becomes positive. Well, the same thing happens with exponents on the fraction bar. If you have a negative exponent on the top, then just simply move it to the bottom, leaving a 1 in its place, and you can make it positive. And the same works if you have a negative exponent on the bottom, you can move it to the top and make it positive. So let's do a few of these so that you can start to see what we're talking about. Now also we've mentioned a couple of times that if I end up with anything to the 0 power, it equals 1. So when we've kind of done a few of these, if I have x to the third on the top and x to the third on the bottom, they all cancel out, leaving us with x to the 0, which equals 1. So anything to the 0 power equals 1. So those are the two rules we're going to be working with. So our first statement, rewrite the expression without using a negative exponent. Well, I have a negative exponent in the numerator, and if I remember my rule, any number with a negative exponent can be rewritten as 1 over that same number with the exponent made into a positive. So in this case, we have a negative 3 for our exponent, so we're going to do 1 over 5 to the third for our positive exponent. How about this one? This would just end up being 1 over x to the positive 7. Now on these two on the right, there's actually a negative exponent in the denominator. So I want to show you what that looks like. If I have 1 over some number with a negative exponent, to make it positive, all I have to do is move it to the top, and it becomes a positive exponent. I wanted to make that an n, not a 2. That should be an n. So there's kind of a double rule there, okay? Just move, if you have a negative exponent, move it up to the top or to the bottom, wherever it is on the fraction bar, and then change the exponent to a positive. So on these two that we have over here, this first one, if we move this 3 to the minus 3 to the top, that becomes 3 to the third power. This 1 over 8 to the minus 2 power becomes 8 to the positive 2 power. And there you have it. So let's keep practicing. So this one would be 1 over 6 to the second. On this one, the only one we're going to change is this one, the m to the minus 3. So we're going to move it to the bottom. So we'll be left with negative 5 times 1 over m to the positive 3 power. And negative 5 times 1 is just negative 5. So you have negative 5 over m to the third power. Okay, keep it going here. 15 to the minus 1 power. Well, we got the negative exponent rule, so we're going to put 1 on top of our fraction, move the 15 to the bottom, and make that a positive 1, which is just 15. On our next one, we have 1 on the top, 2 on the bottom, and then the negative exponent that's on the bottom, we're going to move it to the top and make it a positive exponent, which is what one of those negative exponent rules told us to do. So just like that. All right, keep it going. So I'll rewrite the expression without using a negative exponent. So in this case, the negative exponent is on the bottom. So we're going to move it to the top and make it positive. So 1z to the fourth, and the 4 that was in the bottom stays there. Well, this seems kind of easy. So we're going to rewrite each expression without using a negative exponent. So here's our negative exponent. So in order to get rid of the negative exponent, we need to move it to the numerator of our fraction. So that's going to end up being x to the fourth over 3. Or in this case, 3x times x to the 7th. And we know that we've got x to the first and x to the 7th now on top. Those two would combine to give us 3x to the 8th power. Okay. What about writing these powers of 10 as a fraction? Well, we know that 100 is just 10 to the second, right? So that's 1 over 10 to the second. And if I wanted to move it to the top, I could, and make it a negative exponent, that would be 10 to the negative 2 power. This one is a negative exponent, not a power, so we're going to turn it into a fraction by moving it to the bottom, and so that will become 1 over 10 to the first power. This one will end up being 10 to the minus 1, 2, 3, 4 power. So 10 to the minus 4 power. The next one is 10 to the minus 4 power, so that's going to end up being 1 over 1 followed by 4 zeros. Okay, looking kind of easy. I'm kind of liking this section, aren't you? Okay, let's see how many more we've got. We've still got a few more to go. We've got 3 more slides just to keep you going here. All right, so take a look at this. We're going to combine a couple of these rules. So here's 2 exponents that are being multiplied together, and they have the same base. So you end up adding the exponents. So what's 2 plus negative 5? Well, it's x to the negative 3 power. And then when we simplify it to get rid of the negative exponents, we end up with 1 over x to the positive 3 power. Okay, on this next one, we've got an x to the minus 5 in the denominator. We're going to move it to the top, which will leave us x to the first times x to the 5th. And then you add those two exponents together, you end up with a final number of x to the 6th. Okay. All right, so a couple more we're going to simplify. And they can come in all shapes and sizes, but if we combine those two together, that would equal b to the minus 7 power. And then to get rid of the negative 7, we have to move it down to the bottom of our fraction, which is going to leave us a 1 on top and b to the positive 7 on the bottom. And our next example here, 3 plus negative 5 would give us x to the minus 2 power, which is the same as 1 over x to the 2 power. All right, on our g, or our y to the negative 8 over y to the 8, we're going to flip them upside down. That will give us y to the positive 7 on the top, y to the positive 8 on the bottom. At positive 8, we just say both numbers became positive when we switched them. So now, who has the most, the top or the bottom? Well, the bottom does by 1, right? So this one will get eliminated, leaving us with 1 over y to the first power. All right, for our g's, just rewrite them by moving across the fraction bar. That will give us g to the 5th, and on the bottom we'd have g to the 3rd, right? So then we just use our subtraction rule. What is 5 minus 3? Well, it's 2. So this is going to end up equaling g to the 2nd power. That's pretty nifty when you think about all the stuff all the work that you're saving yourself by knowing these rules. Okay, so we're supposed to write all of these without an exponent. That means if we can get rid of the negative exponent, we're going to actually have to evaluate it. So this would be 1 over negative 3 to the 3rd power, which equals okay, for the next one, negative 8 to the negative 1 power, that would become 1 over negative 8 to the 1st power, or just 1 over negative 8. This one becomes 1 over 2 to the 3rd power, and 2 to the 3rd power equals 8, so this is just 1 over 8. Negative 5 to the negative 2 power would become negative 5, 1 over negative 5 to the positive 2 power. And then when you do negative 5 to the 2nd power, you get 25. So this ends up being 1 over 25. And then we've got to come back up to this first one. We've got 1 over negative 3 to the 3rd power, which in the final analysis ends up being negative 1. And then we've got 3 times 3 times 3, which is 27. So negative 1 over 27. So those are the numbers when we simplify them, and we either get rid of the negative exponent or either get out there and get rid of all the exponents altogether and just simplify it. So hopefully you're enjoying these rules, and we can look forward to doing really well in our upcoming test. Thank you very much. Okay, so our assignment then is going to be on Alex. It's going to be number 57, negative and zero exponent properties. And just remember to show your work either in your notebook, on the back of the yellow paper, or on a problem-solving paper so that you can show your work, take a picture of it, and submit your score and your work. Good luck. Thank you very much.